Hello and welcome to Talk to My Car once again. At Talk to My Car, we make cars talk. Um, yeah, we have ways of making cars talk, as you find out. Today, I want us to look at the basics to electronic engine management. As most of you are aware, most modern vehicles have engines and many other functions like braking and air conditioning and safety like airbags, all that stuff being controlled by computers. Now, today we shall talk about the basics to engine management. Today's cars are way different from the Nissan Stanzas and Toyota DX that we had around in the 80s, which were totally mechanical and had carburetors and stuff. And the manufacturers have very valid reasons for having changed the way cars work, because the modern vehicles are much more fuel efficient and more powerful per cc than older cars. I know some of you, when you get frustrated with modern vehicles, you tend to curse them and wonder what the manufacturer was up to when they upgraded the type of systems that you have on modern vehicles. In today's example, I'm going to use the components of a Land Cruiser, Land Rover Freelander, first generation, which was manufactured by Land Rover from about 1997 or 98 to 2003, I think. There are many variants of the engines in that car, but the most common ones are the TD4 engine. Is an inline four-cylinder diesel engine, and a V6 engine. Now, the example I'm going to use is a V6 petrol. It's called the KV6, and what you have on screen is general view. Now, for anybody viewing this that's not very conversant with what lies under his car's bonnet, I know a lot of you, I don't want to call it allergic, but a lot of you, when you open the bonnet and look at it, you get mesmerized and puzzled and wonder what everything is doing under there and what it is. Now, I want us to learn to get used to what lies under our bonnets. Usually, most of the stuff is quite simple. Yes, allow me to use that. It's quite simple when you get to learn what it does. You by time and again being inquisitive and trying to find out how your car works, you get used to a lot of this stuff. Now, I just want to give you the basics. If you, for example, were looking at this engine, you'd be able, if you knew what you're looking at, the first thing a lot of you would identify would be this alternator. This is a V6 engine, meaning it has two banks in a V shape. You have 3 cylinders on this side and 3 cylinders on the other side, as we shall see more easily in the next slide. But this is a intake manifold, and this is the camshaft somewhere, rather the crankshaft somewhere in there. You've got sensors and wires and stuff, but I will explain that in the next slide, so you get used to some of these components. I can readily identify, you see these guys here, that's probably one of the injectors on that bank, one of the injectors serving one cylinder, and these are probably sensors. You have an oil cap here. You have, this looks to me like the intake plenum. This is probably the mass airflow sensor here. Right, let's get on to the next slide and try to decipher what lies behind this engine. Now, here, in this image, we are looking at the same engine, but a lot has been taken off, obviously, and I think you can now more readily see what some of the important bits that are internal to the engine. For example, like I mentioned, it has two banks relative to each other in a V form. You see this timing belt, the way it lies, that shows you the V form, and that's why the engine gets the name V, and then 6 means it has 6 cylinders. If you look at this and that, those are the pistons on this side, on this bank. The piston is in the cylinders on this bank, and then this, and one somewhere down there, and then this one are the pistons on this other side of the bank, this other bank, and then this one is a flywheel. And you can identify, of course, this is a timing belt. Most of you have seen those. And we have two cams on each bank. This is a camshaft. This is what you call a camshaft. These are actually the cams. You see these teeth? These are the so-called cams. These what look like teeth of that shaft. They are the called the actual name of the cam. That's why you have this entire thing called the camshaft. And then these are the valves. You have intake and outlet valves on any engine. You have those two. Now, in this case, as you notice, you have two camshafts on either bank, meaning, like in this case, these two valves are going to this cylinder, and on this other camshaft, if these are, for example, the outlet, then these are the intake valves for that same cylinder. So each cylinder has 4 valves, and a total of 6 cylinders will give you 24 valves in this case. But a dozen of those would be intake, the other dozen would be outlet valves shared between two banks. And this, in this case, you can actually see, because when you count the cams, there are 1, 2, 3, and another one down here, there are 4 cams, because it's a V6 and it has 24 valves. Right, let's move on to the next slide. And once you've opened up your hood, you've opened up the bonnet, and you're looking inside your engine bay. This is the engine bay. We have our engine here, and then we have other components whose names have been given in the list here. Just to get you used to reading these images, I'll begin pointing out the ones I can identify readily from this list. For example, this is blown up here, but it actually resides in there. It looks like from the picture, it looks like it resides under, rather in the engine bay, but it actually lives in the car cabin, like under the dashboard, on the actual location for this sensor. The APP is actually on the accelerator pedal. APP stands for accelerator pedal position sensor. In other words, this car is a drive-by-wire. It doesn't have a mechanical cable running from the accelerator pedal to the throttle valve, and that's very typical of many cars from 2000 onwards. In other words, with that car, you cannot have a mechanic opening the bonnet and revving the engine from the bonnet. It's impossible. You have to be inside the car to rev the engine, to be able to rev the engine, because um, this guy here, the accelerator pedal position sensor, gives signals to this guy who is the ECM. ECM stands for um, engine control module. Some people call it electronic control module, but there are so many electronic control modules for ABS, for airbags, for gearbox, for a lot of things. So engine control module is more relevant in this case. Now, the APP, for example, would give signals from when you accelerate, when you push down on your pedal. The sensor, the APP sensor, would give signals to this guy, the computer, the ECM, who would in turn operate the electric throttle. This guy here, number 7, who is in this image, he is here. Is this guy here? He's been blown out and put here, but he actually resides somewhere around there, and you can see he lives very near the intake plenum, somewhere after the mass airflow and intake air temperature sensor, but before the intake manifold. And then we have many other guys who live in the engine bay. For example, we have a group of relays who reside here. They have been blown up and shown to you here. Number 2, 3, 4, and 5. Those are the guys here. They live here. If you're looking at the engine bay of 2002, for example, 2002 Land Rover Freelander with a V6 engine, it will be there. And this guy, the engine control module, will live somewhere here in this house. He is actually ventilated via these pipes to your air conditioning, if you have air conditioning and stuff. Because he lives in the engine bay where it gets hot, but he needs to be cool to operate very efficiently. I like this location of the ECM because in most 90s Toyota, the ECM is usually somewhere under the dashboard, and when you have issues, for guys like me who engage in repairing or investigations of engine computer modules, it's a lot of work opening up the dashboard to reach this guy. But in this case, this guy is residing in the engine bay. That's very nice. From where I'm seeing things now, we have many other guys, other computers. IAT means intake air temperature sensor. That one probably lives around there. You have the mass airflow, must be near that one. In most Japanese vehicles, the IAT and MAF are usually put together. They are usually one. If one fails, you have to buy the same component to replace both of them, even if it's just one that fails. Then you have the CMP sensor. CMP is the camshaft position sensor, and the CKP sensor. Now, the CMP sensor and the CKP sensor, between them, they inform the engine control module or computer of the exact position of the engine, and that enables the ECM to give timely sparks and activate the fuel injectors at exactly the right moment for the cylinders to fire in the correct order. Now, the other sensors, ECT, the engine coolant temperature sensor, LH bank left-hand bank ignition coil group. They are probably somewhere. It says here number 14. So they are these guys. This engine is placed in the engine bay transversally. It runs from this direction to that direction. So you have one bank of the V this side and one bank of the V on that side. And so you have a group of ignition coils and injectors on this side, and then the other group of 3 injectors and 3 coils on the other side. This seems like a coil on plug system, which I will explain in future presentation. And you have other guys like the NOx sensor. That one is usual on the engine block itself. Let's see where they put it. Number 16, where you here is usually is under. It must be under the manifold because this is the manifold. And then we have the engine malfunction lamp. That must probably be on the dashboard, which is here. Where is number 19? That's the guy here. If your engine if any of these sensors or actuators malfunction, this guy, the computer, will activate this light to warn you, to tell you to bring the car to talk to my car, so we find out what the problem is. The engine may or may not run when the check engine light comes on. So even if the engine continues to run and you think everything is still normal, well, it's not. And the light is trying to tell you, the computer is trying to tell you, guy, I'm seeing a problem, so take me to talk to my car. So please bring the vehicle. And there is a group of oxygen sensors here. They are usually on the exhaust manifold, one pre and one post the catalytic converter. The front one will be pre, the rear one will be post catalytic converter. Their job is to inform the engine computer module, engine control module of the emissions, the quality of emission that the engine is discharging, whether there is too much fuel, you are burning too much fuel, or burning too much air. When the ECM learns that, it makes correction to bring the ratio of fuel to 1 liter or 1 volume of fuel to 14.7 volumes of air. Now, we have an exploded view here of more of these guys. Most of them we've seen in the previous slide, but I can see this one we didn't have in the other slide, like 24, which is the brake pedal position, no, brake pedal sensor. You have a sensor on the brake pedal for the ABS computer to know when you're braking, and the ABS computer will feed that signal to both the engine and the transmission so that they can engage engine brake when you are braking to aid you in your braking. That's why you see this being mentioned here, brake pedal sensor. You might wonder what it has to do with the engine management. Well, I've just told you. And you can see on the slide. If you are interested, you can pause the slide or the video and have a closer look at all the components that are being shown on this slide. I can see fuses, I can see oxygen sensors, I can see cooling fans. I mean, these are all related to how the engine runs. And the AC compressor relay, which when activated, it informs the computer that you've activated the air conditioning, and the engine gets ready by dishing out more power because you are increasing the load on it. So if it didn't know, if the engine computer module didn't know that you turned on your AC, the car might actually stumble, especially if it is idling, and the engine might die. So the ECM always has to know when you exert extra load. This slide contains typical information you'd find in a factory repair manual. Most of, if you have a vehicle that's come with a manual, that will usually be the owner's manual. It has very basic information. It just tells you how to operate what. And in some cases, it might give you some in-depth, a little in-depth of how some systems work, like radios and stuff. But for the engine, it won't tell you. But it will tell you what will happen if you do X, Y will happen and stuff like that. But it won't tell you how it does it. But the the factory service manual gives you all the information you need to understand how each and every system on the vehicle works. If you are going to work on the vehicle either yourself at home in a DIY format or in a garage, you need this information. That's why these documents are not easy to get. Talk to my car, we usually purchase them, and we can pass them on to you for a small fee. But you just have to know that dealerships like Toyota or Wabamuno, they have this information directly from Mercedes and the license, and they pay for it, and that explains their higher service prices. But with the older vehicles, a lot of local mechanics have been able to get away with a lot of things by learning on the cars that initially come with the technology. They mess up here and there and they learn not to do certain things. But with the modern vehicles, there are too many complex computerized operations going on that is not going to be possible. And sooner or later, any garage that doesn't have the kind of information I'm displaying on this slide, they will ruin a lot of your cars. I'm telling you. And if you're a mechanic and you're out there and you're listening to this, I'm telling you, please come to talk to my car. We are willing to share information on modern vehicles. At least those post 2000 cars. Stop ruining people's cars by doing guesswork. I'm begging you. Right now, if you if you're really keen on seeing the information on this slide, because this is just like 2 pages, but it's a lot of information. Now imagine this information, I got it from a factory service manual for from Land Rover, but I have 3,000 pages of it, and I'm showing you just 2 pages in this slide. So imagine how much information is in a service repair, a factory service manual. And if you're going to repair your vehicle without that information for that specific system, you're going to be ruining your car. And I simply don't understand why you would be interested in investing in a vehicle like this one. And in fact, for most people, a car is the second most costly investment they make in life, second to a house. And then you begin messing it up. Please come to us. We can provide you some of this information for a small fee and you enjoy your investment. For example, in this slide, we have, if I can point out a few things you would learn from this. You see this here? The ECM, that's the engine computer module, memorizes the position of the crankshaft and camshaft when the engine stops. During cranking, on the subsequent start, the ECM confirms their position from sensor inputs before initiating fuel injection and ignition. Now imagine this. You stop the vehicle normally, you take the keys out, open the bonnet. For some reason, I don't know how you can achieve it. Maybe you try to roll the car. You'd call that kujikubando or something. Roll the car, and the crankshaft and camshaft move positions. And next, you want to start the car again. You go back, put the key in the ignition, and now when you attempt to start the car, it might refuse to start. The engine engine control module might refuse to start the vehicle because it thinks something, like, I don't know what has happened, maybe because it memorized the position of the CMP of the camshaft and the crankshaft before it stopped. Now it is seeing them in a different position. It is wondering what happened. And that might bring the check engine light on and tell you, and if you bring it to us, it might tell you to do the timing again. The timing might be correct, but you've just caused yourself a fault. Please, that's why I keep urging you guys who are working on vehicles, please learn to read the things, look for and find the things. These cars are not that complicated if you follow up on the manufacturer's information. Stop telling people these cars they are from hell and that kind of thing. Maybe you are the one from hell because you simply misusing the vehicle, or you simply mistreating it, and it knows when it's being mistreated, and when it's not happy, it will give you hell. And I don't want that to happen to you. Right. You can pause the slide if you wish and read all the information. Unfortunately, I had to divert into giving you all that back info um, about service manuals. Now, in these service manuals, you typically find things like these wiring diagrams. Now, this is a wiring diagram which shows you see this here, that's our ECM, and this diagram is showing you the relationship of the ECM. You see these are um, the terminals at the ECM where each of these wires um, is entering the ECM. If you notice, they have very different numbers. Don't cross them. Don't uh, don't cross wires between these. Never ever. I know a lot of tree shade mechanics like cutting wires, moving one wire from this end to the other end to see what might happen. You are going to burn the drivers in this computer if you're not careful, and you're just going to kill the whole computer if you're really unlucky. And of course, the car will not run. And the slide I showed you before, if you pause to read through it, or it showed these vehicles typically come with immobilizers fitted. Immobilizers mean the vehicle can be immobilized, the engine can be stopped from running if you use the wrong key. The keys in these vehicles have chips which have codes, and they have to agree every time you start the vehicle. The key and the ECM have to agree they are in the same car from the day they were made in the factory and match together. Otherwise, they will never work. So with these modern cars, it's especially if it has an immobilizer, it's not a simple case of you losing your key and going to town or wherever, cutting another key and hoping you come back and run this vehicle. Or if you kept the key but ruined the computer and hoped you'd just buy another computer and put it in, another ECM and put it in, hell no, it's not going to work. A lot of you have found that out already, by the way. So I won't say so much about it. Just know what you have to learn is immobilizers, mess them up, bad news, big time. And if you look more closely at this wiring diagram, and I mean it's all over the wiring diagram, you can see the different colors. Don't ignore that. That is this. I like this diagram because it's showing you the exact colors of each of these connections. So it's to stop you from messing them up, and also eases in for guys like me who do diagnostics. It eases following these wires, following these circuits. And also be careful if you are a technician who is going to work on this vehicle. Do you see, for example, this wire? It leaves this terminal at the ECM as a blue and white wire. Do you see that? Where it is going to the cooling fan control module. This vehicle has a cooling fan control module. But in between there is a connector where it changes colors. There is a connector somewhere on the vehicle where it changes colors from blue with a white stripe to green with a yellow stripe. So be careful. When you go to this side, don't keep looking for this wire. Identify that one, and you should have a direct connection between them. So when you look at this just one page, if you know what you're doing, this thing is showing you a lot of information, loads of information that would save you loads of time if you know what you're doing, instead of relying on guesswork and messing up the car further. I don't know how many times I have to repeat that, unfortunately, because I'm seeing it a lot. We get cars that talk to my car all the time. They've been messed up by previous garages. Usually these problems begin as a small issue. I'll give you an example. For example, in this next slide, let's say the engine is misfiring. You see these guys, these are the injectors. You have 3 injectors, one for each cylinder on one bank, and on the other bank we have 3 injectors as well. Now imagine if this wire for some reason, or through corrosion or something, was to be damaged and this injector wouldn't be firing, so you'd have a misfire. The engine would probably continue to run because you have 5 out of 6 cylinders still working, but you'd lose power. Obviously the check engine light will come on, emissions will be a mess, but and even your fuel trims, I'll teach you about fuel trims in future, but even your fuel trims will be so bad. The vehicle will not run right. And if this wire was broken and you took it to a garage, and imagine instead of tracing the fault to this using the correct diagnostic tools like computers, like the ones we have at Talk Mic and other equipment like oscilloscopes and multimeters, if the guy decided to, for some reason, out of guesswork, get this wire, cut it. I know they do it. By the way, they do it in garages. It's crazy, but they do it. You might cut this wire and try to link it to this one because they both look a bit red, and this one is pink in the middle, the other one is white in the middle, but they closely match in colors, and you try that and see what happens. Now, this is a sensor circuit. It uses 5 volts reference. Now, this is an injector circuit, it uses 12 volts. Mix them up, you're going to ruin this sensor, and then you're going to burn the drivers in this computer, because the drivers in this computer, which are operating this circuit for the sensor, operate on 5 volts. So you are going to burn the transistors and that are controlling this. And you have more problems. This is what I'm trying to tell you. A problem begins as a simple problem, but because it is misdiagnosed and the treatment you give the car is haphazard, it's guesswork, you just ruin up the car some more. And then eventually you have a high bill, and someone will tell you, in the case of a Freelander, let's put a Toyota engine in it. What's the bill? 4 million. Just because of a simple broken wire. Think about that. And here, again, we have another slide, again, of the computer engine control module. This time it includes, you see these guys, these are the ignition coils. They produce the sparks for your engine to run all nice. And here we have some communication wires. This is from the immobilizer. Remember I told you about the immobilizer? When the immobilizer unit computer module is happy with the kit has seen, it will give this engine control module a signal that run. If this guy doesn't get a signal from this guy, the computer will not run. It will not operate, and the engine will be immobilized. So you see, it is that simple. And these guys actually give each other codes. So if you introduce, if this computer was burnt and you brought another one and you didn't match it with this one, you didn't give it the correct code, this one will keep waiting for the code that it was given in the factory from the vehicle that it was in, and this will keep giving another code, and they will never communicate, they will never agree, and the vehicle will never start until you do the sequencing, which costs money, and in some cases quite impossible because we don't have proper dealerships here in Uganda for some vehicles. Even if it was possible, it would be hell expensive. So just beware. Once again, I warn you, immobilizers, don't mess them up. Bad news, always. Um, you can pause the slide to have more of look at this some more, and then here can this can means CAN means this is a network. It's controller area network. It's a network on which all the modules, all the computers on a vehicle speak to each other and they give each other information. So this is an important bit. So if you cut this and this engine computer module, for example, is waiting for information from the ABS module, it will not get it, and you have malfunctions probably with the gearbox, which is also waiting for the same information, and you have a guy that probably is not changing gears, is misbehaving somehow. It might not totally stop. The engine will continue to run, but the driving will be hell terrible until you repair that connection. Yes, thank you for your patience in listening through all this. Thank you for viewing this video. At Talk to Micah, we are here to save you time, money, and headaches. Please, if you have time or you have any queries, you can visit our forum at at the address down here at the bottom. Thank you very much for your time.